steady-state operating curve and a step response. Introduction. I will be describing the voltage system, the steady-state operating curve results, the step response results, and going over conclusions. This is what the pictures of the system look like. You have your motor and your generator, and those are the light bulbs that show your voltage output. Your block diagram for the input is power percentage, goes into the system and then returns voltage output. Your system schematic, where the computer tells the transmitter controller what power to run the motor, and then the generator goes to the voltage from the output from the generator, goes to the transmitter and back to the computer where you get your results. My SSOC trial, this one is at 74% or 84%. It's got transient to about 10%, and then it's pretty much constant all the way across to the end of the time. This is what our SSOC graph looked like. You have your output and your input, and it's pretty much zero for a long time, and then it kind of jumps up, and then it kind of gets linear. You have a upper range, which is linear, and then it's got about a slope of 2, it's from 75 to 85%. You have a kind of a middle range that is from 70 to 75%, which is kind of a slope of 8.4. And then you have a lower range, which has a slope of 0, that's pretty much horizontal, and from 0 to 25. This is an example of the step-up trial. You have your input value, which is your blue line, and your output value, which is your red line. It starts at 79, and it jumps up 6 to 85%. This is how you calculate gain. You have your delta C and your delta M. And my delta C was 11.58, and my delta M was 6%. And then you divide them, and you get K as 1.93 volts per percent. Then this is the dead time calculation, which is somewhat easier to find if you can expand the graph. I had a dead time of about 0.034 seconds, which is really tiny. You got a time constant calculation, your tau, which is solved by using the delta C, and you multiply times the 63.2% to get 7.32 volts. And then you look for your line, and you get a tau of 0.306 seconds. These are the gain results. Overall, this is the average of each section of volts. Had 3 test runs, and this is the average of each section. They're mostly small. We have some exceptions in there. And then there's your dead time results, breaking down into the volts sections and the up and down. Their time constants. For my conclusions, I at the SSOC showed a relationship between input power and output voltage. The upper, mid, and lower ranges do not share the same behavior for the SSOC graph. The step response shows the ups and downs to be similar towards the upper and lower regions, but differing in the middles, like you have your spikes. The overall gain average is 3.53 volts per percent. The overall average in your dwell time is 0.0851 seconds, and your overall average